All right, here's a two-part electric circuit worksheet. Now we're in chapter 18. Basically, I want to talk a little bit about batteries and why batteries go bad, and then introduce series and parallel circuits. So it'll be the same idea as series and parallel capacitors, except the way you deal with the series and parallel is flipped. All right, so a real battery, it doesn't just supply energy and without anything being used up. So a battery, the basic symbol for a battery is this moving back and forth of longer and shorter wires. Inside there's an internal resistance, which we usually designate with little r, and then the external resistance with capital R. So the battery tests it and kind of sees what's going on and figures out, all right, what is the battery going to do? And the symbol that we're going to use for the voltage that the battery is supposed to be supplying is the script letter E. And we're going to talk a little later about the idea of EMF, but it's an old way of referring to voltage before they really understood exactly what was going on. But the battery, 9-volt battery would be 9 volts, but over time it's not going to put out all the 9 volts because itself will be using up some of that energy. Some of the voltage will be used up in this resistance here. All right, and then the battery ends up generating heat at a rate the current squared times the internal resistance. So what happens if you've ever used a battery and over time it kind of heats up, that's what's happening. It's using some of the energy up. All right, I want to talk a little bit more about circuits though. So series circuits, when we have more than one resistance, we can add them up. So in series, we'll start with here. So it's moving along, we have 3 resistances, but the current going through the battery has to go across R1, it has to go across R2 and R3. All of the current goes through all of the resistors. So you end up getting an individual voltage across each one, which equals the total. So we can look through these 4 resistors or 5 resistors, how many resistors, and basically look at the equivalent resistance as all the voltages divided by the current, but because they're the same on the same wire, all the current has to be the same, so you end up with the equivalent resistance for a series circuit is you just add them up. All right, much like when we had parallel capacitors, you added those up. But with parallel circuits, if you can think ahead a little bit here, all of them will be hooked up to the same voltage, because if you look at it, here you have 3 resistors in parallel, but as you look at it there, 0.2 and 0.7 are hooked up to the battery, 0.3 and 0.6 hooked up to the battery, 0.4 and 0.5 hooked up to the battery. So if each one of these resistors acts as if it's by itself to the battery. So the battery is having to power all 3 of those separately. It's doing 3 times the work at once. But somehow, like if R1 was a light bulb and it burned out, there would still be a circuit for 2 and 3. If it was series with R1, R2, and R3, and they're all in the same row and light bulb 1 burned out, then the other ones would go out as well. So in this case, they have the same voltage, but they have different currents. The total current, just add them all up, it's just going to get bigger and bigger and bigger however many you add. And because the voltage is the same, you end up voltage divided by current. But you can't just, adding up on the denominator doesn't mean you can do anything. You can separate those. So what you have to do is do the inverse again. So you end up with the equivalent resistance. 1 over the equivalent resistance is the sum of the inverses of all the resistors. Same thing we did before with capacitors, but this time it's the parallel resistors act the same as series capacitors. Hopefully that doesn't confuse you too much. It's just because resistance is proportional to voltage, where capacitance is inversely proportional to voltage, if that helps at all. We can do series parallel circuits just like we did series parallel capacitors. That's what we're going to spend a little bit of time in class on. All right, thanks a lot, and I'll see you in class Wednesday.